Hi, in this Let's Create series, we're creating a Crossy Road clone like this. In the last episode, we updated the camera and the lighting and implemented the procedural generation of the grass terrain. Now we'll focus on creating the more interesting road terrain type with the vehicles. Let's get started. The first thing we'll do is go into the prefab directory and duplicate the grass prefab with Ctrl D. We'll call this copy road. From the prefab, we can remove the grass script. Then we'll jump into our scripts directory and add a new road script. Then back on our prefab, we can add the road script on. Let's double click on the road prefab to open it up. We could have started from scratch, but it's quicker to delete things. Firstly, we'll remove the trees as we don't want them, and now to update the materials. I seem to have put the materials directory under models. That wasn't intentional, so I'll just drag that back out to the root. In here we need two new materials. The first is the standard road surface. I want it to be a dark grey, something like 50 across the board looks good. Then for the out of bounds variant, rather than going darker like we did for the grass, I'm going to go lighter. This is because the road is already dark, and I think it'll have more contrast this way. Something like 81 looks good. Now we just need to update the height. The grass was done so the top was at y equals 0.2. We want the road to be a bit below the grass so we get a bit of a height dynamic to make the game look more interesting. So what we'll do is just drop the Y position down to 0, so the top of this is then at 0.1. Okay, that looks good. Let's get the basic initialization of the road set up. In the road.cs script, to start with, we'll just implement the init method. This is in the same format as the grass one, returning a hash set of ints, which contains the locations you cannot go to. We start by placing the road in the right position, which again, like the grass, is just put it at the right Z location. Then we'll just return a new hash set using the new keyword and passing in -6 and +6. The only place you can't go on a road is outside the game bounds. The cars will be moving, so they'll have their own collision logic. Over in the game manager, we'll get the roads pulled in and spawning along with the grass. In our variables under the terrain objects, we'll add a new serialized field, private road object called road prefab. The other part of the code we need to update is the spawn obstacle method. Currently this just creates grass, so we need to update it to choose between the two types. We'll use a random number between 0 and 1 to choose the two types. We can then use a new float called road probability to be how likely we want to create a road. You could have this set at a static value like 0.5, then there would always be a 50-50 chance of getting a road or grass. This would work, but you'd get no progression on the difficulty. So instead, what we'll do is we'll start at 50%, but by the time you're at position 250, we'll scale this up to 90%. We can do this with a simple lerp using mathf.lerp function. We want this to start at 0.5 for our 50% probability, then end at 0.9 for our 90% probability. The third parameter then is just where between the 2 points we are. We want this to be 1 at level 250. The level of the prefab is tracked by the spawn location variable, as that's where we're putting it, so we can do spawn location divided by 250. Make sure to include the f on the 250, else it'll try to do this calculation as an integer rather than a float. Now we've got that, we can use it. We can get a random value between 0 and 1 using random.value. If this is less than our road probability, we'll create a road. We'll instantiate our road prefab under the terrain holder into a road variable, just like we do for grass, but make sure you have the type as our road script. Then we call road.init, passing in our spawn location. As with the grass, this returns the obstacles hash set, so we add that to the obstacles list. The height we're passing into the tuple this time is 0.1 rather than 0.2. All the existing grass code just sits under the else branch, and that's all we need. Back in Unity, we can exit out of our road prefab by clicking the back arrow in the hierarchy. On our game manager object, we need to drag on the road prefab, and then we can hit play to test this out. You can see that we've now got grass and roads. And if you go through the level, it should start spawning more and more roads as we get further on. What you may notice is that the character is sitting above the road when they're hopping over it. Clicking on the character, you can see they're still at y equals 0.2 rather than 0.1. Okay, let's exit out of play mode and fix that. In the move character method, we currently have our float y height fixed at 0.2. If we're in the procedurally generated game area, we can get the height from the tuple in our obstacles. If not, we're in the start area and it should always be 0.2. So to see this, we check with an if statement that the character pos.y is greater than or equal to 0. If so, we're in the procedural generation section and we can set y height to be the terrain height of the obstacle at location character pos.y. That would be 0.2 for grass and 0.1 for roads. Let's check that out. We'll jump straight into play mode. Now, when you're moving around, we actually land on the road and we can still move in the starting area. All working well? Excellent. Let's get some vehicles sorted. Okay, so we've got 4 vehicle models. We need to get them resized, colliders added, and create a prefab. To ensure that they're the right size, let's quickly add a road segment at z equals 0 so we can drop them on and test out the size. Okay, let's add in the delivery truck first. Let's make sure it's centered in the road so we can have a good look at it. We'll rotate it so it's heading to the right. We'll sort out the rotation in the code. This just helps with sizing it on our road segment. So we set y equals 90 in the rotation. Lock the scale so we can uniformly shrink it. Looks like 0.6 is our sweet spot. All the other cars are the same scale, so this is what we'll need to do to the others too in a moment. To the car, add a box collider to define when the collision will happen. We also add a rigid body. On the rigid body, we can select is kinematic, as we'll be responsible for moving it around the scene. We don't need the physics engine to do anything. For the box collider, we'll just adjust the bounding box so it sits slightly within the model. Again, you want to give the player a little grace so it makes the game more fun and not overly penalising very slight clips. Once we're happy, we can drag this into the prefabs folder and delete it from our scene. Then it's time to do the exact same thing to the other 3 models. Scaling, rotating, adding the collider and the kinematic rigid body, then saving as a prefab. I've sped up me doing this repetitive task so you don't have to listen to me fill the space by repeating the same process over and over again. If you're adding more than 4 types of vehicles, then you'll have to do even more. With all our prefabs done now, we can delete the road we used for the sizing from our game. Now it's time to jump into the road code again and get them spawning. We'll start first with the variables we'll need. We just have one serialized field that we want to set in the inspector. This will be a list of type rigid body called vehicles. Unsurprisingly, we'll use this to hold our vehicle prefabs in. It's a rigid body as we'll want to move them. And to do it properly, as we've got collisions, we should move the rigid body, not just the transform of the game object. Now we have a few private variables we'll set in the init function and later use in the update to move the vehicles. These are an int called direction, which we'll set to 1. This will end up being plus or minus 1 depending on which way they're travelling. A float speed, which will be a random value to vary the speed of each vehicle moves. And finally, a list of rigid bodies of the spawned vehicles, so we know what we're moving. We'll just instantiate this to an empty list with new. In our init function, we have the placing of the object and returning the obstacles. We're not going to touch either of them, we'll just add in some more code. The first thing is our direction. The vehicles are moving along the x direction. We want it to be plus or minus 1 depending on which way they're going. To get a random plus or minus 1, we can get a random number of 0 or 1, which we do with random.range 0, 2. Remember the upper bound is exclusive. Then multiply this by 2, so the values will be either 0 or 2. Then simply subtract 1, so the options are now minus 1 or 1. The next thing to do is set the speed of the vehicles. They'll all be going slightly different speeds to make it interesting. We also want them to be faster in general as we progress through the level. So for our random speed, we'll want a min speed and max speed. Like with the number of roads, we'll use a mathf.lerp here to interpolate the values between the two constants. For the min speed, we'll go between 1 and 5. Let's make the percentage z divided by 500 f. This means when we get to level 500, all the vehicles will be going at least speed 5. Similarly, for the max speed, we'll do exactly the same but go from 5 to 10. We can then set the speed using random.range between min speed and max speed. Next up, which vehicles and how many of them to spawn. Our vehicles are stored in our vehicles list, so we just need a random index to choose one of them, which can be done with random.range between 0 and the vehicles.count. Let's have a new int, vehicle count, to determine how many we have on the road. I think having up to 4 sounds good. We also want a gap between the vehicles, somewhere between almost touching and a large gap. So for this, I've done a random range between 2 and 6. You may need to adjust the minimum based on the size of your largest vehicle. I'll note at this point there's a lot of magic numbers in here we've baked into the code. If you want to tweak these to balance the game, you may want to add variables which you serialize so you can play with them in the inspector, but I'll leave that up to you. Now the only thing left to do in the init method is to spawn the vehicles. We'll iterate over our vehicle count using a for loop. We'll instantiate into a rigid body called vehicle, as we'll want to store this in our list for moving them. The first parameter is the prefab, for which we choose the one at index IDX in our vehicles list. Crossy Road had each road section with the same type of vehicle, so I've copied that here, but you could equally add a random one each time. The next is where to instantiate it. Our X position of the vehicle is where on the road it is, and we need to space them out. We'll start at I times gap. As we iterate through the loop, I increases, so if the gap was 2, we'd have them at 0, 2, 4, etc. We need to multiply this by minus direction. It's a minus, so they start back from where they're going. The Y is 0.1, as that's the height of our road, and Z is our Z, which says where we are. When creating the prefab, we know that the rotation of Y equals 90 points them to the right, so our instantiation rotation will simply be 90 times direction. Finally, we pass in a transform attached to this script so all the vehicles are created underneath the road game object. Once we've created it, we add it to the spawns vehicles list. That's it for creation. Now the road will have some number of vehicles travelling in a random direction at a random speed. Excellent. The next bit to add is actually updating the positions of them. So we'll add a new private void method called fixed update. Unlike update, that is called every frame, fixed update happens on a physics update cycle, which usually means that it's called less often. I think the default is 50 times a second. Doing any movement with an object where you want to do physics, such as detect collisions, should happen in the fixed update so everything is synced. We'll simply iterate over all our vehicle rigid bodies using a for each loop. Our move amount is a vector 3, where the x component is the only one we want to move in. The amount we want to move is speed times direction times time dot fixed delta time. Speed times direction tells us which way we're going and how fast, and by multiplying by fixed delta time we ensure a constant movement independent of the frame rate. Note that we're using fixed delta time, not just the stock delta time. Now we've got the amount we want to move, we can update the vehicle using move position and passing in our desired endpoint, which is the current vehicle position plus move amount. Move position ensures that the physics engine knows where you've gone from and to, so it can make sure you haven't just sped through some objects. That'll get all the vehicles moving across the game. But once they're out of bounds and out of sight, we want them to wrap around and come back again. First, we'll grab a copy of the current position from vehicle.position. If we're moving in the positive direction, i.e. direction is greater than 0, and the x position of our vehicle is bigger than 12, then we've gone off to the right and we can loop around. I think 12 is enough that the vehicle should be out of view. If it is, we simply set the x position of the vector 3 pos to be minus 12, which will put it back to the start of the road to go again. Then we simply update the vehicle position to the new pos. Note here we're not using the rigid body move position method because we want the vehicle to instantly teleport back rather than to simulate its speed back down the road in reverse to the start point. Then we do the same for the vehicles going the other way, with direction less than 0 and pos.x less than -12. In that case, we set the pos to +12 and update the vehicle position. That's the code done. Let's jump back into Unity. So now if we select our road prefab, we can see under the road script that we have the vehicles variable. If we just expand that, we can press the plus button 4 times to make spaces for our 4 vehicle prefabs. To this, we can then drag on our 4 vehicles: the delivery truck, the police car, the sports sedan, and the van. You can see it's got the rigid body component of each. Hitting play, we can check this out. You can see we've got some police cars, and then some vans, and also the sports car is there too. Also, we've got them going in different directions, so that's all good. If I go all the way to the left, you can see that these police cars are coming, and they leave the scene and we don't see them disappear magically, so that's all good. We should go to the right and check out that direction too. Here the sports cars again drive off, and then disappear at some point afterwards to wrap around. And we can keep going and playing the level a bit. We've really got the core mechanic of this working now. It's really nice. However, you'll soon notice that when you mess up, the sports car drove straight through us. We're an invincible little reindeer. So that's what we'll work on next. That's it for this episode. In the next, we'll detect collisions, restart the level, and add in the UI. I hope you found this tutorial useful in some way. As ever, the full code is on GitHub and linked in the description below. See you next time.